So piston displacement formula. So piston displacement formula, again you draw this curve, piston cylinder, DC diameter of cylinder, okay, and S will be stroke length, diameter, okay, diameter of cylinder, inner side, not outside, okay. But if outside diameter of cylinder is given, you have to check wall thickness. If you are not checking wall thickness, then things will be wrong, calculation will be wrong, okay. So piston displacement is dc square S into rpm or n by 2200. Single acting cylinder, head and displacement, okay, single acting. If you have double acting, so what will happen? Yesterday I told, like, left side volume, right side volume, right. So in that case, PD will be dc square dr square S rpm divided by 2200, okay. dr is rod dia. If you are using all inch, then it will be inch. This will also be inch dc. rpm S will be also in inch, okay. So all your, and PD is CFM, cubic feet, okay, inch 2200 for unit conversion, I think. So double acting, this is single acting, this is also single acting. Double acting, just wait, double acting I will write different formula because 2 DC will be coming. This is head end, this is crank end. What is head end, crank end? Head end means this side, crank end means this side, okay. Double acting you are making, it will be this side, fine. So I am although seal there will be no gap, I am showing here gap so that figure will be clear, okay. So this is single acting. So double acting if we make, so then we have to add, directly you have to add, right. So P or PD we write better, PD equals 2 DC square minus dr square S rpm by 2200. So you see this head end and crank end both are added only, okay. So unit I do not have to write again. So one more formula is there, QA FTQ per minute equals EVPD. So EV equals volumetric efficiency. If you have clearance, piston and cylinder, some gap is there, so some volume will be lost, okay. So that is EV. So volumetric efficiency is there, and gas through, okay. Another formula is they have given, QG equals 35.4 QA PS TS ZS, okay. So gas throughput standard condition, SCFM, gas put standard condition, okay. This is suction temperature, and PS is pressure, and Z is compressibility. This is not TS, this is Z. Z is compressibility. We will go to the problem, a simple problem actually. If you see, in a reciprocating compressor, the swept volume. So first you have to draw the compressor and PV diagram, okay. So Vs or SW you write, swept volume 0.9 times maximum volume, 0.9 into V1. How, what is V1? PV, and if I draw like this, so okay, V1, 2, 3, 4. So 1 to 2 compression. So V1 is the maximum volume. So total maximum volume is given VSW equals 0.9 V1. Okay. So what is the clearance ratio? This is C, VC, this gap. Okay. So VC by VS, they are asking, fine. So V1 equals VC plus VSW, correct. So total volume. So VSW equals 0.9 VC plus Vs. Okay. So VC equals VSW minus 0.9 VSW divided by 0.9. So this is giving 0.1 by 0.9 VSW. So VC by VSW equals 1 by 9. So equals 0.11. Okay. So this is your answer. So simple mathematics, nothing else. There is no complexity actually. Okay. A few minutes are there. I'll try to finish prime mover part. So prime mover. So prime mover, this will be driving your pumps, compressor, surface systems. Okay. So there may be gas turbine systems, there will be reciprocating engine, steam turbines also there, but normally it is not used. Steam turbines will be heavier system, and electric motors are not considered also for as a prime mover. Although motor can be used, but as per definition, it is not included in prime mover. Now, before going through this gas turbine reciprocating engine, you have to know the definition of power torque. Okay. So although you may be knowing, so P equals T omega, you should remember. Power equals torque into omega. Omega means RPM of the system. Okay. Other definition also like force, power, pressure, all load, all this definition actually you should remember. Okay. Everything we may not teach, but those are basic thing you are learning from +2, so you should remember. Okay. First I'll start with reciprocating engine. Reciprocating engine actually you have seen in your cars, bikes, these days trains also, they are diesel locomotives, not aircraft engine. Aircraft engine they use gas turbine engine actually. So same reciprocating engine is used for your genset, normal household applications or like societies they are using. This is very commonly used power producing system. It will be requiring diesel or petrol normally in India, and those will be producing torque. So torque will be used further. Okay, torque will be transferred through shaft, and there will be motor. Motor will be converting generator. Generator will be converting electricity, or maybe in many cases directly that shaft torque will be used for pumping fluid or compressing fluid or many other purposes. So reciprocating engine. So reciprocating engine, it will have piston, crankcase. Okay, it is called crankcase. Okay, it will have again piston cylinder. Same way you have seen your compression system or pumping system. It will have one. Okay, this is called crank. Okay, this is called connecting rod. Connecting rod, this is called piston. This is cylinder. Okay, and there will be valve arrangement also. One, valve 2. Valve arrangements, it will be giving one-way flow. Okay, the main purpose of valve is one-way flow. Like in your heart also, there will be valve, right? So those will be giving one-way flow, not both way. And there will be maybe spark plug. Okay, if you see any IC engine, this will be the basic structure. Okay, there will be 2-stroke engine, 4-stroke engine, auto cycle, diesel cycle. Some engine or some system will be taking diesel, 2-stroke. Okay, some will be taking petrol, and these days methanol operated vehicles, IC engine also available. Okay, and crank will be filled with lubricating oil. Okay, lubricating oil means long chain hydrocarbon. Long chain hydrocarbon, already you know, right? Long chain hydrocarbon, it will give smooth operation of the system. It will be reducing heat generation. So it reduces heat generation and friction. Okay, so when a crank is rotating at very high speed, it will be splashing everywhere inside this chamber, and it will be taking away heat and it will be reducing friction. So that will be, it will be helping. So all the engines should have this lubricating oil chamber. Okay, if your system is not having proper lubricating challenge, or there is some leakage, or you did not change your lubricating oil for a long time, then engine will get heated up. So engine may not start again, or there will be some other issues. Okay, so when crank is rotating, let's say O, A, B, when A is rotating in cyclic order, okay, in cycle, so piston B will be moving up and down. Okay, it will be moving from where to where? TDC, the same term, yeah, you can use BDC. Okay, so one revolution, one time up, one time down. Okay, two revolution means two time up, two time down. Okay, so this is the basic principle of any IC engine you see in motorcycle, truck, bus, your diesel locomotives, everywhere, but not in aircraft engines, because these are a little bit heavier, small, compact you can make, but aircraft engine they need lighter. Okay, so lightweight system, it will be heavier, that's why they do not use, they use gas turbine system. Okay, and piston also will be made like this. It will have piston rings, okay, gauge pin, and this is connecting rod. Okay, there's sort of lots of arrangement will be there. So we'll not go through the details how they are making, but we'll try to see how these things working. Okay, so that you should understand what is two-stroke engine, four-stroke engine, what is emission. So reciprocating engine or IC engine, internal IC engine means internal combustion engine. So all the truck, bus, those are having IC engine, internal combustion engine. Okay, combustion engine. But CI engine also term used. CI means compression ignition. Okay, what is compression ignition? Actually, IC engine will have two parts. One will be spark ignition, one will be compression ignition. Okay, so another will be spark ignition engine. Okay, engine that is spark ignition. I'll explain what is that later. Okay, spark ignition. Okay, there will be IC engine, CI engine, SI engine, right? Spark ignition engine. There will be two-stroke engine, four-stroke engine. So many times in Chennai, if you go outside, some autos will be making too much noise and lots of white smoke will be coming in from the tailpipe. Okay, but many autos will be there, noise will be low and there will be no smoke or anything. Okay, so that says that two-stroke engine, four-stroke engine. Two-stroke engine will have lots of noise and lots of smoke coming out. Four-stroke engine will have complete combustion. Even I think in the in Chennai government order is there, all the autos should be four-stroke engine, so that emission will be lower. Emission means when lots of smoke coming, that means hydrocarbon, whatever fuel you are giving, that is not burnt completely. Not burnt means lots of hydrocarbon will be there, NOx will be there, maybe carbon monoxide will be there. So incomplete oxygen supply is there. That's why white smoke or hydrocarbon vapor coming out. So hydrocarbon vapor coming out means all fuel not burned. That means fuel did not get proper oxygen. That means some carbon will have carbon monoxide also. Carbon dioxide is not harmful actually. Although it's a greenhouse and other thing, but all the engine designers will try to produce carbon dioxide. So carbon dioxide will not give you a problem. Okay, carbon monoxide is having severe problem. So our target will be to produce carbon dioxide, not carbon monoxide. Okay, so carbon monoxide when you are producing, that means fuel not burning. That means all energy you are not consuming. You are giving hydrocarbon in the atmosphere. You are giving carbon monoxide in the atmosphere. So all the things are wrong. So autos and other vehicles, government is saying, okay, don't use two-stroke engine, use four-stroke engine. Two-stroke engine has their own beauty. In many places people are using also. Two-stroke engine will be very much compact. Okay, four-stroke will be little bit heavier. Okay, Now compression ignition and SI, spark ignition engine. So compression ignition engine, actually there will be no spark plug, okay, no spark plug. But SI engine, there will be some compression, but then you are burning fuel using one spark plug. A bike and car, you will have spark plug, okay. So because electric start is there, right. So those you are creating small spark to burn fuel. So how the fuel will be burning? You have piston cylinder arrangement, right. Okay, inside you take air and you take small amount of fuel. Calculated amount of fuel will be injected inside cylinder, okay. So air and fuel mixture you give inside and you compress. When you are compressing, what will happen? Temperature increasing, and high temperature, if you increase temperature very high rate, very high, let's say 2000, 1500 degrees, automatically the fuel will be burning, chemical reaction will start. High temperature means chemical reaction will start, right. So chemical is, that is called compression ignition engine. You are not giving any spark. So compression ignition engine will have high compression ratio. High compression ratio it will have compression ignition engine, okay. But you are thinking about spark ignition, it will have lower compression ratio, okay. You compress up to certain level, then you give some fire source instead of compressing and increasing temperature, okay. You have one cylinder, you put air oxygen mixture, now it is combustible mixture, now it needs some spark. Small spark means small amount of fire if you give, it will start reacting, it will give exothermic reaction. Exothermic reaction means lots of heat will be generated, that heat will be giving, it will be going to another particle, so whole thing will be getting burnt, okay. That is spark ignition engine. But in compression ignition engine, you are not giving spark, you are not giving any fire, you are compressing so high level, so PV and RT, so T will be increasing at very high, pressure increasing, temperature also increasing, volume compressing. So temperature will be very high, so at that high temperature, reaction will start, okay. The hydrocarbon reaction will start and it will burn, it will give power, okay. So you want to go now? Okay, to understand the IC engine, how this is working, you have to understand the PV diagram again, like compression system you have seen. So PV diagram, how can I draw? PV diagram, and my piston cylinder arrangement will be like this, okay. Okay, so piston will have TDC here, TDC here, BDC here, and pressure volume piston, let's say my piston is here now at this moment, and you are starting compressing whatever gas is there, okay. So cylinder is here, cylinder, this is piston, okay. So initially you take certain amount of air and fuel mixture, A plus F, okay. Now you start compressing, 1 to 2, okay. So once compression completes, then there will be combustion. Combustion means after compression, very high temperature will be created, then your burning will be happening, and you reach 1 to 2, 2 to 3, 2 to 3. This is combustion process or heat addition process. Once heat addition done, the piston will be moving from BDC, okay. So 1 to 2 means piston is moving BDC to TDC. Then 2 to 3 combustion will be happening, so there little bit volume also will be increased, so piston will be moving rightward, okay. Then your crank connected here, so crank will get power, okay. So the gas will be expanded 3 to 4. So what the process is happening? Initially it takes certain air and fuel mixture, compress it to 2, then 2 to 3 combustion will be occurring or burning of the gas, whatever air and fuel mixture is there inside cylinder. Then 3 to 4 will be expansion of the gas. So when expansion is happening, that is called power stroke, okay. So one IC engine system, this one cycle 1, 2, 3, 4 will have one power stroke, one compression stroke, this is heat addition, this is called exhaust. Okay. What is happening? Piston is moving from BDC to TDC, you are compressing to 2. When piston reaches to TDC, burning will be happening. So, burning will be happening means lots of hot gas will be created, hot gas will be pushing piston towards BDC. When piston is moving towards BDC, complete combustion will be there at 3. From 3 to 4, piston will be pushed further towards BDC. Okay. So, that is called power stroke, and both cases PV gamma equals constant, PV per gamma equals constant. Adiabatic process we are assuming, this is a very fast process. Okay. Exhaust we are assuming this is isobaric process, isochoric means isovolume process, and heat addition process is isobaric. Okay, PV equals constant or entropy equals constant, entropy also constant. Okay. Now, okay, this is this I have shown 2-stroke engine actually. Now, initially you take air fuel mixture, you are compressing, and after burning piston move backward. Now, what will happen? Backward move, but you did not open any valve, so all the burned gas inside the cylinder. Then how the gas will go out? So, what will happen? Then you will have one port here V1. So, you have to open V1 so that all the gas will be going out. So, piston will be moving towards TDC again. Okay. 1, 2, 3, 4, say 5. Okay, moving 5. All the gas will be going out. Again, piston will be going back towards BDC. When BDC is going, again all air, fresh air will be entering, plus fuel also will be entering. Okay. So, what is happening? OA. So, this A point when you rotating, so one time it will be moving to TDC, one time it will be rotating to BDC. So, what is happening? You have one power stroke and piston moving from BDC to TDC compressing, then TDC to BDC burning, then power stroke, again moving towards TDC, you are removing all the burned gas from the cylinder, again you are moving towards BDC, you are taking air fuel mixture. Okay. So, this crank will be rotating 2 times, you see this crank rotating 2 times, one time going, one time going, 2 time going means 2 time rotation. So, 2 time crank rotation, okay, but you are getting one power stroke. Okay. So, this is 4-stroke engine, 4-stroke. Okay. 4-stroke engine means one power stroke. Okay. One power stroke means 3 to 4, one compression, one stroke compression, one exhaust, one suction of air fuel. Okay. So, 4-stroke engine crank will be rotating 2 times, but you are getting one time power stroke, but you can see all gas will be going out and fresh will be coming into cylinder, there is no mix up of air fuel coming in going out. Okay. So, this is called 4-stroke engine. Again, Otto cycle, diesel cycle, Otto cycle PV diagram will be like this. One, 2, 3, 4. So, in Otto cycle, heat addition is constant volume. Okay. Diesel cycle, heat addition constant pressure process. Okay. So, there will be many other cycles. So, most common diesel cycle, Otto cycle. So, diesel cycle compression will be occurring, then when combustion occurring, so that time piston will be pushed backward and you will get power stroke. But in Otto cycle, you are compressing, then at constant volume process, heat addition or burning will be occurring, then your piston will be moving backward. So, you are getting power stroke. So, here also power stroke. Okay. So, power stroke and compression stroke, these are not changing, only the heat addition, it is constant pressure or constant volume, that is changing only. And if I draw in TS diagram, temperature, entropy and temperature, TS, S means entropy. Okay. TS diagram, if I plot this one, this PV diagram, so it will be like this. 1 to 2 is compression process. Compression means is an isentropic, entropy constant. Okay. Then 2 to 3 heat addition. Heat addition means temperature increasing. Okay. And 3 to 4 isentropic process again. So, entropy constant vertically down. Then 4 to 1 again heat rejection process, so temperature must be going down. Okay. So, 1, 2, 3, 4. Okay. So, in exam I can draw TS diagram or from PV diagram, or TS diagram is given, can you draw PV diagram? Okay. But if I draw for Otto cycles TS diagram, TS, the 1 to 2 is isentropic process, 1 to 2, 2 to 3 heat addition, temperature increasing, 3 to 4 again constant entropy, 4 to 1. So, both curve almost similar. Okay. So, all these are 4-stroke cycles. Now, I will go to 2-stroke cycle.